Hey, Math 110 students, we are in 4.2. We are talking about one-to-one functions today as we continue to build up some ideas that let us get to inverse functions of logarithmic and exponential functions. Now, let me give you kind of a broad idea of what we're going to be talking about today. Let me share with you my calculator screen. All right. Right now on my calculator, I have graphed y equals x squared. Y equals x squared. All right, so this is an original function. It passes the vertical line test. If I drop a vertical line here, it will only touch my graph in one place. Notice, though, that if I drew a horizontal line, that it would cross it in more than one spot. Okay, so we're going to talk about what kind of functions need to also pass not just a vertical line test, but they need to pass a horizontal line test as well. And here's why, because we're going to do inverses. Remember that inverses are functions that are reflected across the line y equal to x. That's what the graph looks like. So the inverse of this function will flip the x's and the y's, and it'll be a reflection across the line y equal to x. Okay. Now, I've got this one already entered in my calculator, and I'll show you what this inverse looks like here for this basic x squared function. All right. So if we flip this across the line, y equal to x, we get this thing over here. But notice this guy, this new guy, is not a function. He does not pass the vertical line test. So the only way for something to have an inverse that's also a function is if we limit the original to the domain in which it's one-to-one. And what does one-to-one mean? One-to-one means that if you turn it sideways, it's still going to be a function, okay? And the way you tell that when you're looking at the original is, does it pass a horizontal line test, okay? Well, this one would pass a horizontal line test from 0 to infinity, but not from negative infinity to infinity. So if I want to take the inverse of this function, I'm going to have to limit it so that its inverse is also a function. And so that's kind of the big picture of what we are doing for the next little bit. All right, so let's go to our PowerPoint slides with that kind of big survey. Hopefully then maybe you can follow along what we're going to be doing now. All right, so we want to know, is a function, we're going to determine whether a function is what we call one-to-one. One-to-one. So one-to-one function is if any two different inputs correspond to two different outputs in the range. Best way to say it is it passes a horizontal line test, okay? So here's a function. It's going to pass vertical line tests. It never has points that lie on top of each other. But to be one-to-one, it also needs to pass a horizontal line test. So it can't have any points that are directly side by side. This one is not one-to-one because you have these points that have the same y value despite different x values, okay? So it's a horizontal line test. So pretty easy to look at, all right? F of x equals x to the 6, okay? F of x equals x to the 6. If you graph that, here's x to the 6, you will see it is not one-to-one. It would be one-to-one from 0 to infinity or from negative infinity to 0. So if you restricted the domain, it would be one-to-one. But the full function with its regular old domain of all real numbers is not one-to-one. It does not pass a horizontal line test. All right. How about the cube root of x? The cube root of x. All right. Here's the graph of the cube root of x. It's a function. It's also a one-to-one function because look, all the vertical lines that we've drawn here, none of them cross it in more than one point. It is a one-to-one function. So a function, and also any function that's increasing on an interval is 1-to-1 on that interval. Any functions that's decreasing on an interval is 1-to-1 on that interval. The problem is if it's increasing and decreasing on an interval. That's when you're going to have points that overlap each other and it stops becoming 1-to-1. All right. Let's look at a set of ordered pairs and see if we can define whether they are 1-to-1. All right, well, the easiest thing is just to graph them. Just graph these guys, okay? Let's see if I can graph them real quick. -3, -15, -2, -10, -1, -5, 0, 0. I'm just going to graph them super fast here on my little thingy, okay? So the list that I was given was -3, -15. So -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A lot low. So I'm just going to draw him down there. -3, -15. -2, -10. 1, 2, 6, 7, 8, 9, 10. -1, -5, -1. Okay, so far it's 1-to-1, 0, 0, 1, +5. Still 1-to-1, 2, 10, somewhere here, 3, 15, somewhere way up here. Yeah, mine's 1-to-1. I passed both vertical line tests and horizontal. No 2 points are going to break the horizontal line test. So just by those set of ordered pairs, then we've got a 1-to-1 function. All right, now let's go back to the PowerPoint. Okay, what is the domain of this one? Well, that's the x values, -3, -2, -1, 0, 1, 2, and 3. And the range is the -15, -10, -5, 0, 5, 1, 10, and 15. That's the range, the y values. Now let's think about the inverse, okay? The inverse is just going to be what you get when you flip the x's and the y's. So the inverse function will be -15, -3, -10, -2, -5, -1. I'm just flipping the x and the y's. Remember, it's a reflection around y equal to x. You flip the x's and the y's. And notice that the domain of the first is the range of the inverse, and the range of the inverse is the domain of the original. Okay? Domain and ranges just switch. Okay? So if the domain of the original was -3, then the domain of the inverse starts with -3. Range of the original was -15, -10, so forth. Domain of the inverse is -15, -10, and so forth. Okay. All right, so obtain the graph of a inverse function from the graph of a 1-to-1 function. Okay. All right, so all it's going to be is a reflection across the line y equal to x. So let's say this blue one is your original, then flip it. If it was AB, then flip it to BA. Okay. You just flip it across the line, y equal to x. Let's do that with real numbers real quick. All right, so I've got just 3 points and it's 1-to-1. And I am just going to flip it across the line y equal to x. And all I have to do this is switch the x and y values. So 3, 3, switch that, still at 3, 3. -2, 4, switch that. Now I'm at 4, -2 down here. Okay. -1/2, 2. Now I'm at 2, -1/2, right about there. Okay. And so our new one is just reflected across the line y equal to x. All right, so there you go. We've got the basics of 1-to-1 basics of 1-to-1 functions. And that's going to help us with the next, where we find inverse functions of one another. Keyword 1-to-1. 1-to-1. All right, we'll see you in the next video.